Unit 7, Day 4. Let's first review the idea of functions, inverses, and those types of ideas. So, f of x is the parabola to the right, and it's not invertible because it doesn't pass the horizontal line test. A horizontal line hits it twice, or we can also say it's not one-to-one. It is a function. For every x there is a y, but for every y there is not just a single x. To restrict the parabola so that it is invertible, let's go from 0 and then to the right. And that'll give us this inverse also going to the right. So from 0 to infinity. Going back to the original f of x, it's 9 here and here when x is 3 and negative 3. On the other hand, when I talk about g, that's this function, and g of 9 is 3 only. X squared equals 4 here and here, and so that's when x is 2 and negative 2. But the square root, see, square root function, whereas this is an equation. In an equation, you must give all solutions that work. In a square root function, one question, one answer. The square root of 4 is 2. So again, E is an equation. You must find all solutions. Whereas in F, this is a function. One question, one answer. So when we talk about trig functions, the same thing occurs. Here we have a sine curve, and it's not invertible because, again, it doesn't pass the horizontal line test. But if I restrict the domain from here to here, then it'll pass the horizontal line test, and they want us to pick one that contains the origin. That's why I picked this portion of the sine graph. We have two names here. Notice that the inverse affects a function, not a number. And we can also write arcsine the same as the inverse sine function. To graph this, we have to now switch the x and y axis, because that's how you graph an inverse. You switch x and y. And so notice now on the y-axis we have our angles, negative or pi over 2 to negative pi over 2. And we have our values from 1 to negative 1. So here's when pi over 2 gives us 1, and negative pi over 2 gives us negative 1. To draw this, draw it so that the curvature, if you were to continue, would go around the y-axis, because that's how an inverse works. The original graph goes along the x-axis. This guy's going to go along the y-axis. So notice that between 0 and pi over 2, you're going to be in the first quadrant, and between 0 and negative pi over 2, you're going to be in the fourth quadrant. And we're going to get to the fourth quadrant by using a negative angle, not by going all the way around into the fourth quadrant. We're just going to go down into the fourth quadrant. So then when is sine a half? what's positive in the first quadrant. Sine is opposite over hypotenuse, so that's 1, that's 2, and I hope you recognize that's our 30-degree or pi over 6 angle. This time our sine is negative, so I'm in the fourth quadrant. And so the opposite is root 3 now, negative root 3, and the hypotenuse is 2. It's a 30, 60, 90 triangle, but now it's in the fourth quadrant, and this is going to be our negative 60 or negative pi over 3. And here, sine is negative 1, when the y value is negative 1 over here, and to get there we go negative pi over 2. We'll do the same thing for cosine. Again, cosine is not invertible because it doesn't pass the horizontal line test. But if I start here and go to here, then this will pass the horizontal line test. It won't loop back up or down and have a horizontal line hitting it twice. So to graph the inverse, let's graph this point first. That's when the angle is pi and the value of the function is negative 1. Then we'll graph this point when the angle is pi over 2, the value is 0. And when I graph this point last, when the angle is pi over 2, the value is 1. Again, when I draw this with a curvature, if I kept going, it would go around the y-axis. That's how you should draw the curvature. So it curves different than the original cosine graph. Again, we can use inverse cosine or arc cosine as our notation. So as you can see here, from 0 to pi over 2, that's the first quadrant. But from pi over 2 to pi, this time we're going to talk about the first and second quadrants. It is positive in the first quadrant and negative in the second. And so I need two quadrants that cover all possibilities. Here, positive and negative will work in the first and second quadrants, whereas for inverse sine, I had to use the first quadrant for the positive value for sine and the fourth quadrant for the negative value for sine. So when it's cosine 0, that's when the x is 0, and that's here, and that's pi over 2. Cosine is negative in the second quadrant. Pi root 2 gives us our 45-degree angle. And so that rotation is 3 pi over 4 in the second quadrant. And then to get a cosine value of a half, that's when the adjacent is 1. The hypotenuse is 2. Oops, drew it backwards. So again, the adjacent is 1, and the hypotenuse is 2. 1, 2. This is root 3. Hopefully you'll see the 60-degree angle coming, which is pi over 3.